Think of a skyscraper. You can't just start piling up steel and glass. You need a plan, a blueprint. In software development, that blueprint is the software architecture. Software architecture is the high-level structure of a software system. It defines how different parts of the software will interact to deliver the desired functionality. Just like a bad blueprint leads to a wobbly building, poor architecture can make software buggy, hard to maintain, and impossible to scale. Good architecture, on the other hand, results in software that is robust, adaptable, and easy to understand. It's the difference between a delightful user experience and a frustrating one. Software architecture isn't about lines of code, it's about the big picture. Imagine a Lego castle. What are its basic parts? You have bricks, ways to connect them, and the overall design. Components are the building blocks of your software. They can be databases, user interfaces, or modules that handle specific tasks. Connectors are the glue that holds these components together. They could be APIs, message queues, or even just function calls. Finally, the configuration describes how these components and connectors are arranged. It's the master plan that dictates how everything fits together. A well-defined architecture makes it easy to understand how the system works and how to make changes without breaking things. Why is architecture so crucial in software development? Imagine trying to add a room to a house without a blueprint. Chaos. Software architecture brings order to complexity. It helps manage the inherent complexities of software systems, making them easier to understand, build, and evolve. This is especially important in today's world of ever-changing requirements and rapid technological advancements. A good architecture results in software that's not only functional, but also adaptable and maintainable, essential qualities for software's long-term success. A stable software system is like a well-built house. It can weather unexpected storms. In software, stability means the system functions reliably even when faced with errors, unexpected inputs, or heavy loads. Good architecture promotes stability by ensuring that different parts of the system are properly isolated. Think of it like compartmentalizing a ship. If one compartment floods, the others remain intact. Similarly, if one module of a well-architected software crashes, the rest of the system can continue to function. This isolation prevents errors from cascading through the system, leading to increased uptime and a more reliable user experience. Maintainability, keeping your software alive and kicking. Software, unlike a sculpture, is never truly finished. It needs constant updates and bug fixes. This is where maintainability comes in. A maintainable software system is like a well-organized toolbox. Every tool has its place, making it easy to find what you need and make adjustments. Good architecture makes software easier to understand and modify. Modular design, clear separation of concerns, and well-defined interfaces make it easier to add new features, fix bugs, and adapt to changing requirements without inadvertently breaking other parts of the system. Scalability, growing your software without growing pains. Imagine your favorite app suddenly gets 10 times more users. Can it handle the load? That's scalability. A scalable architecture allows the software to grow and handle increased demand without sacrificing performance or requiring a complete overhaul. This might involve distributing the workload across multiple servers, optimizing database queries, or implementing caching mechanisms. A well-designed architecture should anticipate future growth and incorporate strategies to accommodate increasing loads and evolving demands, ensuring the software remains performant and responsive even as it grows. Modularity, breaking down complexity. Imagine building a house from prefabricated rooms instead of individual bricks. That's modularity. In software, modularity means breaking down a complex system into smaller, independent modules. Each module has a specific responsibility and interacts with others through well-defined interfaces. This makes the system easier to understand, develop, and test. If you need to change something, you can modify or replace a specific module without affecting the entire system, leading to faster development cycles and more robust software. Reusability. Don't reinvent the wheel. Why write code for something that already exists? Reusability is about creating software components that can be used in different parts of the system or even in completely different projects. Think of it like using the same type of window in different rooms of a house. It saves time and effort. Reusability is a key benefit of modular design. Well-defined components with clear interfaces can be easily plugged into different parts of the system or shared across projects, reducing development time and promoting consistency. Conclusion: the never-ending journey of software architecture. Mastering software architecture is an ongoing journey. As technology evolves and requirements change, software architects must constantly adapt and refine their approaches. By embracing the principles of stability, maintainability, scalability, modularity, and reusability, software architects can create systems that are not only functional, but also adaptable, robust, and ready to meet the challenges of the ever-evolving technological landscape. So keep learning, keep exploring, and keep building amazing software. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.